Hello, I'm going to talk about TinkerCAD in this video. So what I'm going to do is share my screen, and we'll see what happens when I do that. Share screen, click on it. So here I've done a Google search for TinkerCAD, and what comes up is this result over here: TinkerCAD, create 3D digital designs with online CAD. So you may be put off by that and say, gosh, that's not what I'm looking for. But it turns out that's just the splash page, and it is actually what we're looking for. So I'm going to click on this, and what you'll see is it already knows who I am, and my account is over here on the far left. When you click on TinkerCAD by Autodesk, what will happen is it'll ask you to take and create an account for yourself, and you should do that. I used to take and make an account for the class, but that's at this point seems like it's a outdated idea. And what you should do is make a account for yourself. You can see here that, and I used to have classes. Here's one ELE-180 LDO1 and 180 LDO2 for another course. All I really want you to do is be able to get a feel for how you use TinkerCAD. And again, you should take and make your own account. Now, when you go to TinkerCAD, you don't want the 3D drawing. What you want is you want to take, and you can click on this up here, the splash page. Usually that gets me where I want to go. It doesn't look like that's happening right now. So I'll click on designs, and notice it says 3D designs. I don't want that. What I want is down here, circuits. So you got to navigate around the page a little bit, and you don't want, again, 3D stuff, the mechanical engineering type of drawing, the CAD drawing. You want circuits. So I'll click on circuits, and it shows me one. By the way, TinkerCAD will automatically name your circuits for you. So this one's smashing Megillo. Here's amazing Joe for, which there's nothing there. But let's click on this guy. It says Tinker this. So I go and I click on it, and what I have is a proto board here, and a couple components on it, and a meter. So what happens is I can take and tinker this. If I click on it, what it'll do is activate it. And again, you'll have to take yourself and navigate around a little bit. On the right-hand side here, underneath my talking head, are parts. So there are resistors, LEDs, push buttons, potentiometers, capacitors, slide switches, batteries, and so forth. All kinds of parts that you can choose. And there's a bunch of parts, and there's more parts down the very part of this is a limited number of parts, is a multimeter. And the multimeter can be set up, you might notice on the screen here, A for amps, V for volts, and R for resistance. So actually in this circuit right here, which I'll have to talk a little bit more about, if I take and click on it, which I can't do because my head is hiding here. Maybe I can take and get rid of myself. Let's go over there. Start simulation. That's what I want to do. So I'm going to start the simulation. And what happens is you notice that the meter reads 2,000 ohms. Now, let's take a look at this proto board. So if I hover over this, and there's a long row of holes that I can put components in. Notice there's a negative at the top of it. And when I hover over it, they all turn green, indicating they're all connected together. If I hover over this row here with a plus above it, they all turn green, indicating they're all connected together. If, however, I go down here, what I discover is the columns. This is column 28. And column 28, there are 5 holes that are connected together, but that's all they're connected to. 29, they're all connected together. 27, and so forth. So if I go to row 24 here, column 24, what I discovered is the plus lead of the voltmeter is plugged into that, as well as this resistor here. Now, by the way, if I click on the resistor, it tells me it's a 1K ohm resistor. And I can actually take and change that very easily. By the way, as I do that, take a look at the color code. There's brown, black, red right now, which is 1,000 ohms. I'm going to make it a 4.7 k ohm resistor. And you might notice it turned to yellow, violet, red, which is 4,007 ohms. So now what happened is you also could notice that the ohm meter changed to 5.7 k ohms. So these two resistors are in series. And again, I can grab a resistor from the parts bin over here on the right-hand side. I just grab it, bring it out, and again, it'll come up with, tell me what size value it is. By default, they're on 1K. It won't go in the proto board this way. If I put in the proto board this way, what happens is, well, all these terminals are connected together, and I basically short the resistor out. However, what I might want to do with the resistor, and it's still outlined there, so what I might do is go over here, or let's try this, rotate, and sure enough, I can rotate the resistor. Now, let's take a look here. The resistor is not connected to anything. It's connected to this column 26, this column 30. So what I'm going to do is grab it, pick it up, and move it over here. Now the two ends of these resistors are connected. I'm going to take this guy, I'm going to highlight that, and what I do is toss it in the trash bin. It's gone. I just hover over the terminal here, and I bring it over to this column here, and now if I click on it, it makes a connection there. By the way, I might not like that color green, since it's the red lead of a voltmeter. Let me go over here, and I'll change the wire to red, and that's more of our color coding. Now, let's go and start the simulation, and sure enough now, I get 6.7 k ohms because I've got a 1K, a 4.7 K, and another 1 K ohm resistor here. And again, if I hover over them or click on them as I hover over them, they'll tell me exactly what they are. And I could just change them by going up here into this pop-up box and inputting a new number. And the colors will change automatically. So the proto board is what you use in a lab, and it looks very realistic. Nice graphical interface here. And again, we're just measuring resistance. What if I click the voltmeter to volts? Well, there's no voltage across there. How about amps? There's no amps across there or flowing in that circuit. There's no power source. So speaking of that, let's go back. Let's leave it on volts here. Let's grab a battery. And I'm going to grab this battery, and I'll bring it over here. What I'm going to do is twist it around. I don't know what this one does. Let's see what happens with that. Nothing. So I'll go and twist the thing around and pull it back over this way. So I've got a plus and a minus. So what I might do is take, well, let's spin it around a little more. So now I have the wires like this. So let's take the minus, the negative, and go over here to that. And let's take the positive over here and go over here to that. And maybe I'll change the, oh, now I did it. Let's hit escape. Yeah, if I hit escape, I get rid of that wire. Let's go and highlight this guy, and let's make him black. You don't have to do it, but it's nice to have things color-coded. Now, what I might do is go over to this guy, throw him in the trash can, go over to this guy, throw him in the trash can, and then go and wire from here, and then wire from here. And of course, I might want to change that last wire to red, if I get the right thing here. We'll do that. And now, if I hit start the simulation, I can read the voltage of the battery. You know, if you've been following the course, you know we're looking at series, parallel, and combination circuits now. So it turns out that TinkerCAD can do a lot of these calculations for you or make measurements for you. So what I'm going to do here is I'm going to go and do this. I'm going to run a wire from here. Well, I got to take and stop the simulation, I guess. I'm going to run a wire from here over to this column. So now I've connected plus voltage to that. I'm going to run a wire from here up to the negative. I should make that a black wire. Indicate it's a negative. And let's take and put my voltmeter. Let's get rid of this guy. Throw him in the trash can. And take and bring him down and put him right there. And of course, we'll color him red because he's the red one. Now I'm going to run the simulation. And what I see is my 3 resistors in series. This guy, let's follow that, by the way. The electrons come out of the negative part of the battery, I'll talk about that in a second. They come out of here, go through this wire, down here, through this resistor, up here, through this resistor, up here, through this resistor, back down here to this wire, back to the positive side. That's what the electrons are doing. My voltmeter is across this resistor by virtue of the fact that I'm looking at, well, actually what it's across is these 2 resistors. If I take and kill this guy, highlight him, and throw him in the trash can, and let's go do it this way. We'll go now down to this guy. Let's make him black like that. So now if I run this, start the simulation, what happens, you see the 7.65 volts is actually across the 2 right-hand resistors. If I want to take and get a reading of other voltages, I could grab another meter and I could go across like from here to here and run the simulation. And when I do that, notice it's negative. It's negative because I've got the 2 leads backwards here. I should take and let's throw them into the trash can, that guy. Let's throw this guy into the trash can here. And I should put the red lead as close to the battery as possible. So I'll click on that one and I'll make it red. Then I'll go here with a black lead. And I'll go over here and I'll make that black. And what you'll see is that when I start the simulation now it turns out they're okay. So what I'm seeing here is 7.65 volts across these 2 resistors and 6.31 volts across this resistor. That's really all the information I need to tell what are across all the resistors. This one, I would take 9 volts and subtract 7.65. That'll tell me what's across here. If I know that the 7.65 across here and 6.31 across there, all I got to do is subtract the 6.31 from the 7.65. That'll tell me the voltage across this 1 k ohm resistor. And so why don't I just take and put a couple more meters in here. Here's one, and I won't be too worried about the color coding here. I'll go from here and over here. I'll go up here. And that should be a red wire. So I will color code that. And now when I run it, we see 1.34, 6.31. Notice that 6.31 and 1.34 add up to the 7.65. That's Kirchhoff's voltage law. And the last thing, I'll put 1 more meter in here, and I'll go with that meter over here. I don't know if you could put it on the proto board, you probably can. And I'm going to go here, and then I'm going to get another wire and go to the other end. Am I running? No, I got 1 more hole I can put in there. And that wire should be a black one. So let's put that as black. Now I'm going to take and run the simulation. And I see that this guy here, the 1 k ohm resistor on this end, has the same voltage as a 1 k ohm resistor on the other end. Why is that so? Because it's a series circuit. The same current passes through each resistor, and the voltage across the resistor is proportional to what? The current through it. So 2 1 k ohm resistors have the same current, therefore they have the same voltage across them. If I add 1.34 volts with 7.65, I'll get 8.99, which is the voltage of the battery. If I add 1.34 to 6.31, I get 7.65. If I take and subtract 6.31 from 7.65, I'll get the 1.34 and so forth. Everything totals up. So you can do this type of operation, and certainly you can use parallel circuits. So if I want to make parallel circuits, let me just show you. A parallel circuit would be if I took and let's see where I can go. I think I have, if I move this guy down here, can I move him? Maybe I got to stop the simulation. If I move this guy down like this, I think I have room to put a resistor from here over to there, maybe. Well, I'm looking where I can put some resistors in parallel. I've kind of used up, well, from here. No, I don't have any wires. I don't have any place where I can put the wires. Let me just show you a couple parallel resistors down in the other portion. By the way, there's a space here. There's no connection between these columns and the columns down below. So let me just go and show you here. I'll grab a resistor here, bring it out. I'm going to rotate it around. Okay, so here we go, and I'll put it just here, and I'll grab another one, rotate it around, and I'll take and put it here. So maybe I'll just finish this off by saying, okay, let's take and use a meter. Let's bring that guy back. Let's use a meter to measure the resistance between those guys, or of that parallel combination. So I'll grab a meter, and where am I going to put it? I'm going to put it down here, I guess. And I'm going to put a wire from here to here. And I'm going to put a wire from here to this column here. So what I'm doing is I'm measuring the parallel resistance. Well, those are two 1,000 ohm resistors. If you've been studying the parallel resistors, you know that I can determine the value of that by taking those two equal resistors, take the 1,000 divided by the number that are there, which is 2, gives me 500 ohms. And so if I go up here to start simulation, all the other voltages will be the same as before. Oops, I left out a voltage. I want to make a resistance, and you notice it's 500 ohms. So again, circuit maker, you want to play around with it, and it can take and you can build circuits, nice graphical interface. And actually, the other thing it can do is, which is not for this course, but for other courses, it can take Arduinos and program Arduinos and run Arduino programs. So that's a quick introduction to TinkerCAD. I like using it. It's a lot of fun. There's other circuit simulations software we'll get into, and that'll be Circuit Maker. Well, we won't do that till next semester. Or maybe we'll do it towards the end of this semester. Okay, that's it for this one.